molecule will be having some kind of, some kind of hydrocarbon chain will be there. You'll have a hydrocarbon chain like this. These are all tentacles, which are also nothing but hydrocarbon molecules. And then you have some kind of long slippery tail, which is there, which is also a hydrocarbon. So this is what additive molecule can be depicted as. Okay. Now this usually has got a sticky end. And okay, so consists of, if it is having a sticky end, normally that is occurring because of active groups which are containing either oxygen, nitrogen, sulfur or phosphorus. इसमें कुछ ना कुछ N atom, O atom, sulfur atom, your phosphorus atoms will be attached in either single or double bond. They will be there. So that's why this forms a sticky end, while the slippery tail which is there, it consists of hydrocarbon chain. So this is a long hydrocarbon chain which is there. Generally, this is the depiction. You don't need to worry about exact formula of the same, because that is very complicated. Now talking about the ashless dispersants. When we talk about ashless dispersants, first of all, what is a dispersant? If you can tell me, what is a dispersant? Am I audible?
Sir, dispersants are chemicals that are sprayed on a surface, oil slick, to break down the oil into smaller droplets.
Oil into smaller droplets, you're saying?
Yes, sir. So that they can readily mix into the water.
Not exactly. If you're talking about water, yes, it will keep ensure that the some small amounts of water droplets, they get mixed with oil, other way around. But main function is not to mix water. Yes, that is also one of the functions. The main function is to ensure that the sludge, the
they do not combine
particles. Yes.
So they form a thin layer over the sludge particles, so they do not combine with themselves to form larger sludge particles.
Yeah, that is correct. But apart from that, they are doing one more thing. They are causing this entire sludge, solids, water, and all to remain in suspension thoroughly or homogeneously distributed throughout the oil. The reason being, if the water or sludge or solids or soot accumulates at the bottom, it will get caught into the filter. It will block the filter. The water may cause corrosion. It can cause other problems also in the system. So that is why we have dispersants. Now, when we say ashless dispersants, they are particularly very important when we talk about the lube oil being used for cylinder lubrication as well. Because if it is forming ash, then the oil, when it is burnt in the cylinder liner, some of it will get burnt during the cylinder liner lubrication. It will form a lot of ash. So ashless dispersants is the term which is used. Okay, so what they will be doing, they will be controlling the sludge, amount of sludge formed, control the sludge and varnish formation at low operating temperature. They will control the thickening caused by soot. So soot may be formed, so they will try to keep that soot homogeneously, distributed across the entire lot of lube oil, and not just the oil which is there in the crankcase. There are high molecular weight tail. The tail is very high molecular weight with surface active head. The head is surface active. So head will attach itself, and the molecular tail, that high molecular tail, is a long chain hydrocarbon basically, and that is the one. And it keeps the sludge, soot, deposits, okay, all these things suspended in oil. Okay. So this is just try to depict that how these dispersants will be working. So it's just a picturization or visualization of the same. It's just that which is there. Okay. So we have here you have the dispersant molecules with a long or heavy tail. This is the sticky part which is going to stick. These are some solid particles which can be it can be sludge particles, the soot particles or whatever. And here you can see the action of the dispersant has taken place. The dispersant molecules have attached themselves all around the solid particles, and they have kept these particles apart. They are not, it's not allowing these particles, two particles or more particles, to join and aggregate together. Aggregation is slowed, and when the particle size is remaining small, when the particle is uniformly distributed because of remaining small, when the particle is actually very small, obviously it will remain more evenly distributed and more evenly homogenized within the entire lube oil. So need to control soot thickening, sludge. Too much of dispersant may affect the seal performance. What seal performance? What seal it is talking about? Any idea what seal it is talking? Not exactly that one, because that seal is dependent on basically the viscosity and the viscosity index, and to some extent by the flash point of the oil. This is talking about the seals which may be used, like O-rings and other seals which may be used, lip type of seals or something which may be used in the system. So it may affect the seal performance. It's talking about that. I'm not really sure how it affects the seal. That I have not gone into, but it is going to affect the performance of the seal in the sense that seal will become hardened and all over a period of time, or seal may become swollen over a period. So it may affect the life of the seal and also the performance of the seal. So I think that's all for today's class. I think I'll be ending now. We have done till dispersants. Just remind me, and we'll be going into the detergents. Okay.